Hello friends, welcome to our channel Mathematics by Fun Art. Today let us see the 11th question of exercise 10.2. Prove that the parallelogram circumscribing a circle is a rhombus. Let's first draw the diagram. Let's draw a circle. We have to prove that a parallelogram circumscribing the circle is a rhombus. Let's draw a parallelogram circumscribing the circle. Let the center of the circle be O and the sides be A, B, C, D, such that AB is parallel to CD and CB is parallel to D, that is, which gives us AB is equal to CD, as this is a parallelogram. Let this be equation 1. And we can name the points of contact as P, Q, R, S. We have to prove that the parallelogram circumscribing, that is ABCD, is a rhombus. To prove ABCD is a rhombus, for a rhombus all sides are equal. We have to prove AB is equal to BC is equal to CD is equal to AD. We know that the vertices of the parallelogram are the external points of two tangents drawn and they are equal. According to theorem 10.2, we know that tangents drawn from an external point are equal in length. According to theorem 10.2, we can write AP is equal to AS, BP is equal to BQ, CQ is equal to CR and DR is equal to DS. We'll write them. AP is equal to AS, BP is equal to BQ, CQ is equal to CR and DR is equal to DS, according to theorem 10.2. Let this be equation 2, 3, 4 and 5. Adding them up, adding equation 2, 3, 4 and 5, we get AP plus BP plus CR plus DR is equal to AS plus BQ plus CQ plus DS, which gives us AB plus CD is equal to AD plus BC. We know that AB is equal to CD from equation 1. Substituting equation 1, we get AB plus AB is equal to BC plus BC. Since it's a parallelogram, AB is equal to CD. Similarly, BC is equal to AD, which gives us 2AB is equal to 2BC. Cancelling out the 2's, we get AB is equal to BC. We also know that BC is equal to AD and AB is equal to CD. Since all sides are equal, the quadrilateral, the parallelogram circumscribing a circle, is a rhombus. Hence proved. Thank you. Happy learning.